good day, everyone, and welcome to the very first session of UP Manila SILab's IOL 101 webinar series 2025. I'm Gabby Velasquez, SILab's Communication Officer, and I'll be facilitating today's webinar session. All right. So last year, we have an incredible run of our 2024 webinar series, both for the first and the second leg. And we have learned practical knowledge and real world case studies, mostly from our very own UP Manila Celeb experts. And as standards and interoperability lab here in the Philippines, of course, we envision achieving universal health coverage through digital health capacity building, data portability, and appropriate use of health technology. That's why this year, we are bringing you fresh topics, diving deep into the latest trends and challenges of digital health and interoperability. And we will learn from a diverse pool of experts, both locally and globally. And we will have more elevated discussions, as well as more relevant content focusing on in depth explorations of digital health interoperability, AI, and other real world case studies. And of course, this webinar session will not be possible without the support brought by the Strengthening Standards Capability Project, or the SSCP, of CSIRO, or Commonwealth Scientific and Industrial Research Organization of Australia, as well as their Department of Foreign Affairs and Trade, or the DFAT. All right. Now I invite virtually to join us UP Manila Silab's Lab Manager, Sir Manu Gaspar, to briefly introduce UP Manila Silab's community of practice. Sir Manu, over to you.
Thank you, Gabby, and hello, everyone. This will just be quick, and especially to new attendees, I'm excited to invite all of you to join UPMC Lab's Community of Practice. Our Community of Practice is a vibrant and growing group of experts and practitioners who are very passionate about advancing standards and interoperability. Join us in shaping the future of seamless data exchange by joining and signing up to receive our newsletter as well as our WhatsApp group. I will be pasting the link shortly over chat, but you can also scan the QR code on screen. For the next slide, we would also like to invite all of you to express your interest to join the Digital Health Interoperability Bootcamp being held on 4 to 6 February 2025 at Manila, Philippines. This bootcamp is co-organized by UPM SILab in collaboration with CSIRO Australia as part of the Strengthening Standards Capability Project, or SSCP. This bootcamp will help you develop essential skills on modern technologies, healthcare standards, and interoperability. So, lots of hands on workshops in developing FHIR-enabled digital health applications using different tools like Onto Server, Google Open Health Stack, Smile Clinical Data Repository, and 8box. So please join us. Express your interest. I'll also be pasting the link shortly. But for any questions, please email us at clab.upm@up.edu.ph. Thank you, and back to you, Gabby.
All right. Thank you so much, Sir Manu, for that. And so, may I introduce our speaker for the very first session of IOL 101 Webinar Series 2025. So, Mr. Jing Tang, a staff software engineer at Google Health, driven by a passion for using technology to improve health equity, has a background in computer science and artificial intelligence, with projects spanning robotics, theorem proving, and model and temporal logic. So, before joining Google, Sir Jing gained industry experience in digital media and finance. And at Google, he has worked in ads and mobile development, and since 2020, his focus has been on Open Health Stack and the Android Fire SDK at Google Health, aiming to make a healthcare more accessible and equitable for all. Beyond his technical work, Sir Jing is an activist supporting multiple charities, focuses on healthcare and international development. So that's very exciting. So to give a deep dive on the Open Health Stack, let us all virtually welcome Sir Jing Tang. Sir Jing.
Thank you so much, Gabby, for the intro. It's really exciting to be here. Thanks everyone for having me. So I'm gonna start sharing my slides. Just give me 1 second. I think given the fact that I think from the survey we saw that some attendees didn't manage to attend the first intro to the Open House Stack session. I'm just going to spend about 30 seconds sort of bring up everybody up to speed. Can people see my slide?
Yes, you can see your slide.
Great. So our mission at OHS Open Health Stack is to help accelerate the development of next generation healthcare solutions to help developers build high quality AI powered healthcare apps. So we have a number of components in Open Health Stack, such as the Android FHIR SDK, the FHIR Info Gateway, and FHIR Analytics. So these components help developers build faster, help developers build solutions that enhance the privacy of the patient data, as well as unlocking the insights. There's a number of ways of using these different solutions. Really, they are designed to be sort of componentized. They're designed to be easy for you to choose what to use and create your own ecosystem using the different components, as well as playing with other sort of open source tools and solutions that's in this space, right? So one of the things that we have been doing in the last year, especially, is to sort of exploring Open Health Stack components, working with existing healthcare solutions such as OpenMRS, such as OpenFN, and whatever other sort of software libraries or components you might have in your system. So that's just a very, very quick overview of Open Health Stack. If you didn't manage to see to attend the session last time, please do go and revisit the recording from Fred. So onto the topic today. So today we're going to do a bit of a deeper dive into one of the components of Open Health Stack, and that is going to be the Android FHIR SDK. Let me start presenting these slides. Right, so again, my name is Jing. Very excited to be here. Thanks everyone for having me. As I mentioned, the Open Health Stack components, there are a few of them. Specifically, the Android FHIR SDK is one of the things that we created at the very beginning, trying to help developers build Android apps that are secure, offline capable, and configurable. But most importantly, leveraging the healthcare standard, which is FHIR. It is written in Kotlin. So Kotlin is a modern programming language. It's been around for a number of years, but I think especially in the last few years, I would say, it's really become the sort of primary language of Android development. It's modern, it's very elegant, the code is easy to read and easy to write, and that's why we chose to use Kotlin. And I think it also opens up the sort of door for Kotlin multi-platform solutions in the future. We can talk a bit more about that. And obviously, it is on Android, the biggest operating system in the world. So I think especially in a lot of low and middle income country settings, Android has a very, very vast reach, and it really helps developers to enable healthcare workers and patients with the patient data and insights. So we have a few design principles that we laid out at the beginning of the work. So first of all, open source. We are part of the FHIR open ecosystem, and we're part of the open ecosystem of global digital goods as well. But I think maybe one really important thing to call out here is the different sort of models of open sourcing libraries, and in particular, our model of working in the open source space is to have not only the source code open, but also the development process very, very open and transparent. So what that really means is that we really welcome developers to send code, send contributions to the repository, and we will discuss these issues, discuss the code with developers, and we also hold developer calls every other week to go through any issues that people may have come across during their integration or when they're contributing to the repo. So it's not just a sort of open source in the sense of the source code is out there for you to see, but also you can really participate in the entire process of development. It is FHIR native, as I say. Well, the clue is in the name. It's called Android FHIR SDK. So being FHIR native is a very, very important part of Android FHIR SDK. The data is stored as JSON, which I will talk about a bit more, as JSON documents on device. But because you have this like native model of FHIR running on the device, it really opens up the doors to do fairly complex and advanced operations on the data. And it really allows the app, the application that you build on Android FHIR SDK to communicate with different systems. It's offline capable. This is something that, again, very, very important, and we really had this point in mind from day one of creating the Android FHIR SDK libraries. Really, it's about allowing healthcare workers with Android devices to be able to deliver care wherever they are, right? If they are in a remote setting, if they don't have good connectivity, they could still interact with the applications. They could still access the patient data on the device. But obviously, that also comes with a very, very important sort of security considerations. And that means we do have to pay additional attention to making sure the data is safe and secure on device. And then finally, the last design principle is clinical workflow awareness. What this means is that we are leveraging some of the concepts and implementation guides in FHIR to make sure that when you are building applications using the SDK, you could put together different sort of steps of the workflow and create your own sort of clinical workflow. We have built a couple of libraries, the Knowledge Manager and Workflow Library, to support this use case. Right. So how does this work in your system? Right. So the Android SDK is a set of libraries, and then you, as a developer, could build applications on top of that using the SDK. And then the Android SDK also could ingest the FHIR implementation guides. So I kind of hinted on this. So these are sort of definitional artifacts that you might have in the FHIR. Either as the sort of published artifacts by HL7 or by other organizations, but you could ingest these implementation guides as guidance for the SDK to behave in certain ways, and then apps built on top of the SDK could also interact with the FHIR server, and this is a very important part. So you could download and upload FHIR resources. This could be patient data. This could be sort of other auxiliary sort of FHIR resources that's defined in the core spec. Through this syncing process, right, you're allowing your device to hold some of the data that you need to operate on when you're in an offline setting. I'm seeing a message asking the slides. Can I just make sure that people can see my slides?
Yes, sir, we can see your slides.
Okay, that's good. All right, I'll continue then. Right, so now on to the libraries of the Android FHIR SDK. So the Android FHIR SDK as an SDK is not just one library. We actually have a number of libraries in the SDK. So at the moment we have 4. They are the structured data capture library, the FHIR engine library, the knowledge manager library, and workflow library. So these 4 libraries do sort of very different things. And the common thing, excuse me, the common thing about these libraries is that they are all built on top of FHIR, leveraging FHIR resources, making sure that your app is interoperable, right? But they have very different focuses. The structured data capture library is a library for recording, collecting patient data using questionnaires. So in FHIR, there's this specific implementation guide called SDC, or Structured Data Capture. It basically standardizes the way of collecting patient data using the questionnaire resource and the questionnaire response resource defined in the FHIR spec. So the SDC library is an implementation of the form filler in the SDC implementation guide. It has the questionnaire API, so it allows you to display questionnaires on the phone. It has validation API and data extraction and population APIs. We'll come into a bit more details in the next slide. The FHIR engine library is a very, very important library in SDK. It's important, well, because it's the engine. It is the library that really drives the storage and the sort of management of FHIR resources on device, right? So it has a database that keeps FHIR data on device, but it can also sync with the backend FHIR server or FHIR servers, and it allows you to interact with the resources on device via search API. The Knowledge Manager is a library that we created last year. So it stores and manages the knowledge artifacts defined in FHIR. So that's a bit different from FHIR engine in that it's not really to do with sort of the patient-centric data, which FHIR engine stores in the database. The Knowledge Manager stores sort of larger, more static definitional resources from FHIR, and it stores those data in the the file system and indexed in the database. And that's because of the different sort of profiles of the reading and writing profiles of the different resources and the characteristics of the different sort of files. So we have chosen to implement a very different storage in the Knowledge Manager, separate from FHIR engine, to accommodate the different characteristics of those resources. And again, we'll come into a bit more detail. And then finally, the workflow library is one that sort of allows you to create care plans for patients, allows you to run measure reports and generate measure reports for the data on device, and also go through the activity flow pattern defined in FHIR to carry out sort of the workflow for patient care practice. Right, so those are the four main libraries really quickly. I think I've already talked a little bit more detail, but just to really give people an idea of what they really do, right? So the SDC library, I think I quickly mentioned that it uses questionnaires to collect patient data. But really what it is kind of a UI library where we have built a lot of different widgets that allows you to turn questionnaires that's defined in FHIR into UI components. So for those of you who have done Android development, I think you may have experience of sort of writing UI code or fixing UI bugs. It is a particularly sort of time-consuming and difficult thing to get right, and especially get to a very high level of fidelity to the UI design. And we built the SDC library to sort of address that issue. What happens here is that if you have resources like questionnaires defined in FHIR, the SDC library will automatically generate the UI for you, meaning that you don't really need to sort of test and rewrite the UI code for your particular FHIR questionnaire. Because of the existence of the definition in FHIR, we're simplifying that process for you. So what we have heard from developers in the past is that this has really dramatically sped up the development of their applications. Some of them said, actually it reduced the development time from by sort of 50% in their particular case. So I think that's a really exciting sort of use case and benefit of using the SDC library. As I say, it provides kind of different widgets to present the questions in the questionnaire defined in FHIR, but it also has quite a rich set of features, and we have been really improving the library a lot with a lot of help from the developer community to kind of iron out the edge cases, to provide sort of support, for example, expressions, support for validation, support for extraction and population. Right, so what that means is it can really use sort of all the features defined in the SDC specification and have a very rich interactive questionnaire pretty much with very little cost of development. So onto FHIR engine. Again, as I mentioned, it really handles the storage and the management of resources on device, and we have the core of this is the encrypted on-device storage SQLite database. So we do store the file resources as JSON documents, but we also do add index, so different index tables for the resources stored on device to facilitate search. Right. So there's a set of data access APIs for CRUD operations. So these are reading, sort of basic read and write operations that you might need when you're interacting with file resources. But we have also built a fluent search API. So what this is you can sort of basically use when you're writing code in your IDE. I'm assuming probably Android Studio in this case. You really can get very, very nice sort of autocomplete features, and then the code that you write is sort of reads very nicely in this Kotlin DSL, which is a domain-specific language. We have obviously like examples on the repo and the demos on the repo as well. So if you're interested in using this Fluent Search API, please go do and check it out. And then finally, a very big part of the engine library is the sync API. So the sync API lets your application to upload and download resources from and to your backend FHIR server. There's two modes of the sync. You can either trigger a single sync job, or you can trigger a periodic job, right? So in some cases, if you have spotted sort of connectivity, you're not sure really when you're gonna be able to upload and download, I think a periodic sort of sync makes a lot of sense. But in some cases, if you have just sort of collected the patient data and you want to upload the data to the server, or maybe you know that there's new information on the server that you need to download in order to carry out some of the operations offline, then you might want to trigger a single sort of a one-time sync job. So there's a lot of different configurations. So the underlying library that we use is the Work Manager in Android. So that gives you a lot of additional capabilities to manage your sync jobs, such as you could specify, for example, you only want to sync when you have enough battery left in the phone, or when you are sort of connected to Wi-Fi, for example. So I spoke about sort of Knowledge Manager. A little bit more detail, I think. So what are the definitional resources we are storing using the Knowledge Manager, right? So they are things like plan definition, things like activity definition, the definition of measures in FHIR, and potentially terminology sort of resources as well. So as I say, this is sort of a kind of a utility library really to manage these resources separate from your patient data. So in practice, this acts kind of almost invisibly, like in your application, because the sort of the the workflow library and SDC library and the FHIR engine library will sort of automatically pull resources from this library in their sort of operations. And the workflow library finally is the one that puts the workflow together, but specifically implements the sort of the clinical reasoning module of the FHIR specification. So underlying and the underlying library of the workflow library is actually the CQL sort of Java libraries that have been developed by the SMAL CDR group. So we depend on the CQL engine so that we can run the clinical quality language expressions. So they can be used then to either generate care plan or run a measure to create a measure report for a patient. Or it could be used to sort of go through the activity flow. So when you have a for example, a medication request or prescription, and you can actually use the workflow library to act on that prescription, act on that sort of medication request, and go through the stage of planning and ordering, and then marking that medication request as filled. So this operation may sound simple, but actually requires quite a lot of very intricate sort of management of different file resources which are interconnected, and this connection and a lot of these operations are defined in the clinical reasoning module in great detail, and sort of it's not something that's very intuitive or easy to implement for developers who may not have spent a lot of time reading the clinical reasoning IG in FHIR. So the library that we have created here, the workflow library, really is to help you create applications very easily. You know, even if you're not an expert in clinical reasoning in FHIR, you could still use the APIs to build apps that sort of conform to the patterns that's defined in the FHIR specification. Right, so now we have arrived at this diagram. This is my favorite diagram for Android FHIR SDK. It's the architecture diagram that puts everything together. So let's see how this works. So I'm going to start from the bottom up, right? So if you look at the bottom left, we have the SQLite DB, which is, as I mentioned, the foundation of the FHIR engine library, which sits on top of the database. The engine library can then talk to a FHIR server to the left, sort of uploading or downloading file resources. Right, so that's one part of this. And on the bottom right, you have the FHIR, the knowledge manager library, which, as I mentioned, actually stores the knowledge resources in the file system with the help of index in the SQLite database as well. And the knowledge manager library can interact with the knowledge repository, a knowledge server, to download sort of definitional resources in the form of an implementation guide in FHIR. So these two things are kind of like the foundational pieces, right? Because they, you know, manage the patient data and also manage the knowledge artifacts that you may need when you are operating on the patient data. And then on top of these things, on top of these two libraries, you have the SDC library and workflow library. So they are kind of more practical, closer to the actual flow of the applications. The SDC library, you know, you may load patient data, you may load the questionnaires from the knowledge manager, you may load the patient data from the FHIR engine to generate the UI using the SDC library in your application. And then the workflow library may again load sort of the workflow aware file resources, such as the plan definition, activity definition, or the measures. And then they might load also patient data in order to take the sort of some of the requests through the activity flow, for example, filling a medication request, right? So these two libraries, sort of, I guess they're kind of like in the mid layer to support your application in the Android FHIR SDK. So that's kind of the bottom half of the diagram. So these are the Android FHIR SDK libraries working together. And then on top of that, obviously, you still have to have your own application. You may have your app-specific UI. You, of course, will have the business logic that you need in the application, right? So your app will be using the Android FHIR SDK libraries to fulfill sort of the use cases. But a really, really important point here is actually the four libraries, although in this diagram they're all there, you can pick and choose. You don't have to use all these four libraries in your application. So, you know, if you are just starting out, getting familiar with SDK, really a good way to do that is to, you know, maybe pick one library, and quite often that's the SDC library, to start trying to write some Android apps using FHIR resources, right? And then maybe if that works out very well, maybe you actually want to store some of the information you have collected using the SDC library in the on-device using the FHIR engine library. And then once that is done, perhaps you want to actually use some more FHIR resources to guide your application through a clinical workflow using the workflow library and the knowledge manager library, right? So there really are different patterns of putting sort of these 4 different libraries to use. Again, it's not, they don't have to all be in your application. You could start with one library. They all stand, but the reason that they are 4 different components is because they are independent. They can be used independently, but also can be used together. Right, so I've talked quite a bit about sort of the different libraries in Android FHIR SDK. We actually also have developer resources, guidelines, and other tools in the Open Health Stack website and our repos. So as an example, we have the demo applications in the Android FHIR SDK repo. We have 2 demo apps. The first app is basically an app sort of to showcase the capabilities of the FHIR engine library. So you could use this app to sync patient data with your server. And then once the data is synced, you could search through your patient data. You could register new patients, and then you could start like assessment. So that's very similar to a lot of the flows that are typically sort of used in a sort of community based patient care application. And then we have the SDC catalog app. So SDC refers to the SDC library I mentioned earlier. So this is the app that has all these different widgets and sort of layouts that sort of shows you how the SDC library would render a FHIR questionnaire. I will show you a video actually in a minute. But through this app, you can really see when you design a FHIR questionnaire, when you have like a radio button or autocomplete box, how that really works in the SDC library when you use the SDC library to render those UI components. Let me try to play this video if I can. Can you see my screen? Can you see the video being played?
No, it's not playing at the moment.
I think I need to share a different tab. I'm sorry. Just give me 1 second. Can you see now? I think I'm sharing a different tab.
Yes, it's playing.
Okay, cool. So I'm going to sort of pause a little bit here because so this is kind of the UI of the SDC library. I know it's kind of scrolling very fast, but these are all the sort of widgets we support in the SDC library. And then if you look into one of the example questionnaires we have, right, you could actually answer the questions sort of by selecting the right options, and then you could interact with the questionnaire, type in different answers over standard, but also we have examples that show you how some of the dynamic sort of operations we have support for in the questionnaire. For example, when you are answering a specific question, another question might be enabled or disabled depending on the answer you have provided for the first question. So this is something that's very, very useful and very sort of commonly requested as a feature by our developers. And this is something that's called enable when in FHIR. This kind of slightly more complex operations and dynamic sort of behavior of the form is actually really, really important when it comes to improving the performance, improving the efficiency of healthcare workers. So we really do believe that having this kind of support is useful for healthcare applications that you will be building. Yeah, there's some sort of other widgets such as date and datetime. We have applied the material 3 design guidelines in the design of this application. So So really, like when you are using the SDC library in this case, just by having the library in the dependency, just by having FHIR questionnaires sort of translated into Android UI automatically, you already you get the benefit of kind of compliance with some of the latest UI guidelines and designs as well. So that's like a huge win, I think, for developers. Right, let me come back to the other tab. Sorry for the switching. This one I can actually show, I think. So this is another demo. This is the another screen in the demo app that we have built, right? So this is where we actually use the demo app to sync with the backend server, and you could actually use the search API to filter through the patient. So in this case, we have built a two sort of search boxes for filtering patients through the first and last names. But obviously, the search API supports all the search parameters defined in FHIR, meaning that you can actually create fairly complex search queries to suit your needs in the application. It also includes things like include and reverse include and nested search queries. So it really can support fairly complex and advanced use cases. Right, I'm going to speed up a little bit. I think we almost sort of at time. I want to leave some time for questions. I think I've seen some coming through in the chat. So we also do have code labs in the sort of OHS dev site. We have two code labs, one for the SDC library and one for the FHIR engine library. Kind of step by step shows you how to use the library to build your first Android FHIR SDK application using FHIR. And it also goes through some of the setups that's probably quite useful even outside of this setting. You know, the FHIR engine code lab actually sort of runs you through the steps to set up a happy FHIR server using the Docker image. So that's a very useful exercise, I think, even if you're not using Android FHIR SDK. As I say, it's an open source repo, so feel free to go and check it out on GitHub. You may participate by raising issues, by sending PRs, by writing some code, or sort of even if you want to just do some code reviews and look at like the code other people have written that's currently in review, you feel free to go through those PRs as well. So it's a very open and transparent development process that we are running. There's a few other ways to get involved. We have a bi-weekly Android FHIR SDK developers call. It's very well attended. We have a sort of very active and vibrant ecosystem of developers from all over the world. And that happens every other Thursday. We participate in the WHO Smart Guidelines Working Group, and we also run a workflow evaluator implementation call with clinical reasoning developers. But if you want to get involved with any of these, feel free to reach out to us. We have a lot of information on the dev site, and we also we have a Medium blog post, and we also have some videos on YouTube. I think there's one about IntelliSoft and one about Owner, but just go and check it out. Check out some of these links. And then finally, we have a developer forum. So that's ohs.discourse.group. So we have recently started this, but we're really hoping that this is something that would allow people to sort of discuss the issues that they may have, especially for the community to help each other. If you have any questions, maybe a developer who have done some similar integration can help you with that. And just so for that kind of interactions, please do feel free to go and check out the forum. And then obviously you can directly reach out to either Fred or myself. Yeah, I think that's the end of my content. I'm happy to answer some questions. Thank you.
Thank you so much, Sir Jing, for that wonderful discussion on OHS. Let me just share back my screen. Hold on. But I'm opening already the floor to questions from the group. Again, you may use the raise hand function. You can type in your questions in the chat box, or you can use the Q&A button if you want to ask anonymously. So the floor is now open for Q&A. So I guess we have questions in the chat box. Let me just read. So are there any SDKs or software development kits available for other programming languages such as PHP or JavaScript in addition to the Android SDK?
Yeah, it's a great question. The FHIR ecosystem is very active and actually very very big. It consists of many libraries, tools, developer groups working on these things. So what I would suggest is really to check out the Confluence page for FHIR. I think I can actually post the link in the chat. There's for sure JS implementations. I'm not sure about PHP specifically, but there's for sure C++, Java, and many other languages implementations of FHIR. So you can check out those things. I think in terms of Android FHIR SDK, obviously we have developed this thing in Kotlin, and it's really for Android development. But we are looking to potentially expand the sort of the reach of the SDK by looking into some Kotlin multi-platform sort of explorations. It's still very, very early, but I think that's a direction that we probably will start taking. And obviously, if there's any change to the SDK or sort of like the next version of the SDK, we will definitely reach out to the community and get some feedback.
Thank you. And I guess this is related to the question earlier. How about for iOS implementation? Is there a Fire SDK available for iOS?
Yeah, I would say it's very, very early days, to speak about sort of Kotlin multi-platform. But I do want to say that I think it's possible, and there is sort of a migration path that we can see to kind of apply the SDK's kind of technology and the sort of the functionalities we have built to the iOS audience. We're beginning to sort of look at some of these options and working with some of the groups that we have already been working with to explore the possibilities. So I would say stay tuned. So at the moment, it doesn't support iOS, obviously, but I think with Kotlin multi-platform being more mature, and with us building up some of the additional capabilities, it will be a possibility in the future.
Thank you so much for that. So I would just like to read a comment by Dr. Alvin Marcelo, our very own director at UPM SILab. So he mentioned that it is very interesting if we can link the OHS or the Open Health Stack apps to the PSA or the Philippine Statistics Authority APIs for identification. And there was a response as well, or to fill health for claim query. So Doc Eloy, are you in the call? Maybe you would like to add a few insights regarding this one, sir. Sorry to call you on the spot, Doc Eloy.
Yes, thank you, Gabby. Thank you, Gabby. In fact, Jing, Fred, there are some APIs coming out right now from national government on citizen identity, location identity, organization resources. I think the fire standard is coming in quite late before all of these location, organization, and person identifiers have been established. So, but it's not too late. I think there's an opportunity to bring all of these together. I think the Open Health Stack app and the framework, can be a point of consolidation. All of these different APIs right now. So there's a different agency of government handling the identity API. That's the Philippine Statistical Authority. There's another organization, the Department of Health, maintaining the location and organization resources. They are not yet FAR compliant, but if you look at the data sources. It's just a matter of massaging the data to make them FHIR capable. The worker registry is in the process of development, but in fact, the workers are actually citizens. So they would be first citizens and would have identities in the Philippine Statistical Authority, and then added role of midwife, nurse, or doctor, and they get stored in the worker registry. So I think the planets are aligning in terms of what are the registries that need to be available. And then now we're presenting Open Health Stack and the Android Fire SDK as a set of building blocks, so to speak, to put together all of these diverse APIs. So that's why my question was, how trivial or how hard do you think would it be to build a prototype Open Health Stack application that consumes these APIs from these national agencies? Of course, we would be asking for test uh, and synthetic data, but if they do make available those APIs, how trivial or how easy would it be for Open Health Stack to consume these APIs?
I think. Oh, can you hear me? Oh, Fred, like over to you if you have a hand up.
No, I was going to speak after you. I was just no, go for it.
I think it kind of, so thanks, Dr. Alvin, for the question. I think it really depends on some of the use cases we have to sort of look into very, very carefully. The APIs are open and very, in my opinion, very easy to use. And we have had examples of people interacting very quickly with SDK. And that includes sort of not only the front-end components, right, not just SDC, but some of the data layer sort of interactions as well. So I think it really depends on the specific use case, but I do believe kind of early integration, kind of prototyping work can be done sort of very, 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 very quickly. Yeah, over to you, Fred.
Yeah, thanks, Jing. Yeah, I suppose I just conscious of the time. I also wanted to maybe just propose that we Jing and I discussed this, and obviously there's a lot more to Open Health Stack. I mean, the Android Fire SDK is a really big project in and of itself. It's got a lot of very rich functionality and features, and so we wanted to allocate all of the time to really kind of going into that. But as Jing highlighted in the beginning, there is also the info gateway, which looks at enforcing access control policies and things, and the data pipes, which is for basically generating insights, doing analytics on data that's collected in FHIR. So if there's interest following up from this, we'd be happy to schedule maybe a follow-up kind of deep dive where we can probably try to cover those two topics in one additional session, or maybe we need two additional sessions. So yeah, just in case people were wondering about the other components as well. But thanks, Jing. That was great.
Yeah, I think those components will also be very useful in terms of building out the sort of entire system, right? So the Android components is like only one aspect of the system, sort of to Dr. Alvin's question. And then just to call out the comment Fred made in the chat. I mean, I think I was answering the sort of iOS question or the sort of multi-platform questions in the context of the SDK, the Android Fire SDK. But really, like looking at your own implementation, you may just want to look at some sort of iOS projects that's available in the ecosystem, right? So Fred sent a link from the Stanford group, but there's others out there as well. For example, there's the FHIR models project for Swift. So do take a look at the entire ecosystem, and I think one of the most beautiful things about FHIR is the fact that it's very open, very transparent, and people are contributing back to the ecosystem. So do take note of the other sort of open source tools and projects as well. Thank you.
Great. Thank you so much, Sir Jing and Sir Fred, for that. So Do we have any other question from the group before we formally end this session? So I actually believe that we might need one more session after this one. So are there any other questions from the group? Okay, I believe none.
Thank you, Jing. A big hand for Jing Tang, please. Thank you.
Thank you very much, Dr. Alvin. Thank you, Gabby. Thank you. Appreciate this.
Thank you so much, sir. And now, before we formally end this session, may I invite everyone to please turn on your camera and let's have a group photo taken. Again, thank you so much, Sir Jing, for that very wonderful discussion on OHS. Okay, and just briefly, let's wave to the camera for around 3 seconds and for the video highlights. Okay, 1, 2, 3. All right, great. Once again, thank you all for joining us today and making this session a success. So remember, the conversation doesn't have to end here. And so once again, I am inviting you all to join our IOL 101 webinar series 2025 scheduled every Wednesdays. So flashed on your left side of the screen is the list of topics for the month of January. And on the right side of the screen is the invitation for the expression of interest in joining the upcoming Digital Health Interoperability Bootcamp Manila. All right, once again, thank you. This is Gabby Velasquez. Have a great Wednesday and see you next week.